Have to get started. All right. So welcome to this ending keynote. They told me that since it's the last session of the day, I can unleash a lot of concepts on you, so I promise you will leave this room with a headache. It will be an avalanche of concepts, stuff that I normally cover in 8 hours of workshop. I will try to squeeze in your brain in 1 hour at the end of a fantastic conference, at the end of the first day of a fantastic. So, enjoy. Okay. My name is Victor. I am a Java champion of Romania. You've seen 3 of us today. After I'm in this branch for 17 years, but about 8 years ago, I realized that coding was not enough for me. So I started helping the others, looking around in other teams, and this has become now my full-time job. I'm doing training and consultancy in companies throughout Europe. My favorite topics are clean code architecture and unit testing, but you can't really talk about these topics until you master the frameworks that you're using. So since I'm a Java guy, Spring, Hibernate, and Reactive is what I do very often. But the more, like, let's say, hardcore team, call me for performance and secure coding. I just finished a training on secure coding on Monday and Tuesday. So if you want to know more, there's the full description, and you can find many of my talks already online on YouTube. But besides that, I try to do every month, 1 hour of a discussion with my community. Now, several years ago, together with some friends from IBM, she's here, one of my colleagues back then, we started a group on Meetup, just to have a place where to share ideas and to learn from others. Now that group has grown beyond my wildest dreams. 5,000 members from throughout all the world. What happens over there? Every month we get together one day, and we talk after hours for 1 hour about a certain topic. After which we debate, and there are roughly usually 100 live participants debating different topics. So this is completely free. It's fully COVID-free, COVID-proof, remote. Like Romania likes it, and if you want to join, it's completely free. There's the link. Good. I have the past events on that community recorded. So, and I started having guests from other people talking. Very fun things happen in there. All right. Now, besides work, I have 2 children and a cat that wakes me up in the middle of the night. Here's the cat. So that's my life. Good. So let's turn back time a bit until the dawn of the Agile. And there was a thing back in that manifesto and those concepts called emergent design or emergent architecture. Any one of you has ever heard of emergent design? Why not? Why so few? Why so few? Because it doesn't sell. What the heck is that? Let me tell you the story. We are supposed to let the design evolve while we ship code. The design is supposed to evolve naturally towards the optimum. Nice dream, right? So what happens? That emergent design never emerged, and we kept shipping. All right? So people need triggers. I needed triggers. 17 years ago, I needed a kick in my ass, refactor now, right? So what can give us this feedback, these triggers, these kicks, right? Tests. Tests are the missing piece that was forgotten, that was neglected from all the Agile things, the technical practices, including test-driven development. But I won't say TDD because some people take it very religiously. So I don't want to go there today. No, just tests, many tests. So this is my favorite guy. This is my favorite, next to Evenkat, of course. This guy is my favorite guy. He is one of the creators of Agile, basically. The most technical form of Agile there is. Extreme programming is called. He's the inventor of TDD, the author of JUnit, and considered to be the father of unit testing. He's God. But you don't hear much of him because he's from the United States, so that doesn't travel much. But this guy had some rules back then, 20 years ago, called rules of simple design. And I want to start from these. The first rule, it passes all tests. Many teams stop right here, and what does that mean? Just if you don't have tests, how can you prove it works, right? Then, expresses intent. You might have heard of this as the single responsibility principle. Ubiquitous languages, people reinventing the same ideas. Expresses the intent in clear terms. Doesn't do duplication. Don't repeat yourself, right? and is minimalistic, the least amount of code you can write to get the job done. Today we'll focus on this part because it's not only about proving that your code is correct, it's about listening to the design, to the feedback about the design that the tests give you. So this is where we are. Okay, do you know what this is? What does this feel like, huh? It's an ice cream cone. Thank you. That's the ice cream cone testing anti-pattern. These are 130 manual testers testing with the mouse. There are a few automated robot Selenium tests. This is the reality in most successful monoliths. You know them being also known as the big ball of mud, or the place that you want to run away from. Anyway, the Spartans that remain have 20% coverage through robots, 0 coverage through integration tests, and they are just starting putting some unit tests around there. Now, this is not what we do, what I see today in most companies. We have testing pyramid. Who has heard before of the testing pyramid? Wow, so that's like half or 1/3 of you. We have here the test that would cover the whole flow, starting from the click in the UI, everything, end to end. We have the integration test that tests the whole system, right? Or basically parts of that system, like several modules coupled together. And here below, the unit test. The tests are fine-grained, focusing at a small single piece of behavior, right? The more up, the higher you go, the more integration you have to face. The lower you go, the more isolation you are looking at. Of course, these are very flaky, fragile, and very, very expensive to run. I have a client that runs tests for 24 hours. They have a dedicated server, a cluster of servers just to run their robot tests. Okay, these are very, very expensive up there, right? Good. Now, the more critical flows that you have in your application, of course, you want to test them to make sure the checkout works, right? I mean, like, imagine EMAG. Would you like to know, if you were the manager of EMAG, that the checkout works? Of course you want. And you will run that continuously, right? Just to make sure. Down there, there is that weird corner case of that weird, very, very unlikely situation of that edge corner case, right? The pyramid wants to say that the overlapping is intentional. The checkout flow will, of course, include some stuff that you also unit tested. All right? There you go. That's a testing pyramid. Now, are you familiar with mocks? Whoever has used mocks before? Mocks. Oh, that's more like it. Oh, yeah. Do you love mocks? No, don't answer that. Don't answer that. Mocks. So down there below, there are mocks because you want to decouple code so that you can test the little bit that you just wrote, the little small parts. Right? So mocks, love or hate? No. Die, like the emperor, right? Die. But there we have reasons both to love them and to hate them. The reasons to love mocks would be because they allow us to write our tests super isolated from the external systems, right? You can have a green test even if the system you were supposed to call is down. But now you have other alternatives, right? Like the blue whale. Or faking the JSON response you get from another system, right? One more question. How many of you are implementing backend systems? Backend system, maybe also backend systems. Okay, so that's like 90%. All right. So we love isolated tests because we want to have them reliable and repeatable, right? Fast. Now, this is the king. You can't ever compete with 100 tests per second or 500 tests per second run with Mockito in memory. You can't beat that. I have a client in Cluj with 25,000 tests in a couple of minutes. And the part that we actually turn to very often, too often, is that it allows us to write our tests simpler. Just focus on that little method we just wrote. And there is a trap in there, and there is this guy called James Coplin who doesn't agree with this. And who says literally, sorry, I intentionally put it there so no one can read it. It's a dangerous article. It says, why most unit testing is waste. That's anarchy. But interesting perspective. Now, cyclomatic complexity, we will need these concepts. Do you know what that is? Cyclomatic complexity? The number of paths, independent paths that you can have through some code. It's a rough approximation of how many tests you need to go everywhere, right? Now, the fun thing happens when a function with cyclomatic complexity with 5 execution paths calls another function with 6. How many tests would you need if you want to test both? 30. Yeah! 30 tests. Yeah! At maximum, you usually require 15, 12, not 30, but that's the maximum, right? So you see what happens if you want to drive a test through the whole checkout of Emag, actually they do that, but you would need like millions of tests because there are so many combinations. Plus, the input you pass to the checkout, it would be like a JSON of 4 kilobytes, right? Like, you can't just, you need many and heavy tests to go all the way. So in a sense, mocks are inevitable. Okay, why do we hate mocks? Why do we hate mocks? Any idea? It couples with the implementation. If we test from too close by, we will get fragile tests. Yeah, we will get fragile tests that break whatever you change in the internal structure, right? But besides that, I want to share you the love of some teams that I work with that have thousands of tests in production, and that when they, oops, I don't think I have internet here, or did I? Yeah, it works. Amazing. Look, the unit test. Does this correctly lock the door? Unit test. Unit test. Yes. Now the integration test. Yeehaw. That's better, right? Or my personal favorite, production. Excellent. And then it opened, you know? So these are what? These are examples of unit tests. If you put the whole picture, it breaks, right? Very frustrating, right? Very, very frustrating. And one more reason to hate mocks from anonymized examples straight from mock, and it continues. Then the test. When, verify. And now the fun fact. Do you know how much production code they were testing here? 4 lines of code. Of production code, and they wrote this madness of, and they were asking for good reason, what the heck am I testing in here? What am I testing? You can't see exactly. You know what saves you? These comments here. If I would delete these comments and wipe out the empty lines, you're dead. You will take 30 seconds just to understand what you're calling, right? So, test has 20 lines of hell, and production has 4 lines. How do you feel? So, what could you do to this? If you have a very maniac colleague, he would tell you, burn the test. Doesn't work. What are the chances that such a code would break? I mean, there is no if inside, right? That has a cyclomatic complexity of 1, for Christ's sake, 1 test. I can't tell you that in a discussion about unit testing, can I? I can't tell you that. No. What I will tell you instead is to question this function. Do you really need this function? Do you really, really need it? Can't you just collapse? This is a code smell, by the way. It's called middleman in the book. Right? Can't you just kill the function, inline it wherever it's called? Sometimes yes, sometimes no. But you should think. Tests ask you, hey, do you really want to have this as a function? Do you really need that function? Because if you do, you have to test it. How do you test it, right? Unit testing, this is a mistake. Unit testing, this is a mistake. You either destroy the function or what else? It's hard. We don't know each other that well. With some of you do, yes. But what else could you do? What? You could test from farther behind, from farther away. That's called honeycomb testing. Let's see what that is. You remember the pyramid? Breaking news. That's for monoliths. It's like 25, 30 years old, this idea, right? And that's for monoliths. But then how do we test microservices? You know, monoliths are special in one regard. They are highly coupled pieces of code that have only a few entry points, just several, I don't know, 20, 40 entry points, and behind that, 1.5 million lines of code. And I'm not making up these numbers. 1.5 million lines of code with 40 entry points. How the beep do you test 1.5? You can't really test at the API. You need unit tests, a lot of unit tests. Quick fact, you realize that the surface is proportional to the quantity, right? Many. All right. Now, how do we test microservices? You know, microservices accumulating this kind of complexity in a single system is a mistake. You should break the microservice, like I'm going to catch you. Oh, I'm going to catch you, right? You should not have that kind of complexity under a single microservice. So, in microservices, we have much more APIs, much more surfaces to attack the complexity. So what's the follow-up? It's called honeycomb testing strategy from Spotify. You have these top of the pyramid is the same. They integrated fully end-to-end with all the microservices put in action, everything up and running. Super expensive, usually a QA automation team, not usually your job. Your microservice or microservices, several, and then that microservice has some flows. What do? You struggle to test the whole thing from the API. That's the change. You don't start with writing unit tests. You start by writing tests at the API level, many tests at the API level, right? So Spring Boot test if you want to talk dirty, Java. Good. So then, of course, you want to keep these tests isolated. So what would you do? You would connect them to a wire mock or to a Dockerized dependency, right? So you can have it under control. And with that, I think I just nailed what half of you are doing, right? And like, just back, or you want to be doing. Anyway, good. And then what happens if you run into that terrible piece of complexity to apply discounts to a shopping cart? Imagine there are 400 ifs just for that section, right? Will you be able to test everything from the API? Probably not. So you still need implementation details, but mind that it is less, let's say, the surface is less wide than this one. What does this mean? There are fewer. And you create them only to test that piece of complexity that really, really, really kills you, right? So, and you are allowed to play mocks in there, all right? That's a drama, right? That's a change in strategy. You start testing the API and you dive into unit testing only if you have to, if you are facing terrible complexity, right? Good. So what am I saying here? The first rule is that the first lesson from unit tests is that you should not employ mocks in a simple flow. If you can manage the complexity of both components, both classes, test them both together, right? Make sense until here, right? I mean, don't employ mocks if you don't really have to. That's basically the first lesson. Now, the benefit is that if you decide to refactor the interaction between B and A, to change a method, to add a parameter, the test will still work, right? Because you've tested at the surface. So any internal refactoring inside that component will not break. I mean, outside of the bubble, right? I promise that you'll have a headache. So from now on, we will only focus about this part because this is where the tough complexity will accumulate. If you don't have that kind of complexity, don't go there. Stick here in the integrated tests, the one that's just go through. If you're Java, it should be super simple. Right? Spring Boot test against test containers or wire mocks, and write as many of those you can. Good. First chapter. I have chapters. Chapter 1, unit testing puts more design pressure on methods and data structures. Here's the method in production. The rest of the presentation will look like this. Here is the production code. We wrote it, and then that production code, to test that production code, for example, a method that takes a big object, and out of that big object, the method actually only uses 2 attributes, 2 fields inside. Do you see that? Like I'm creating a customer, and I only care about first name and last name. Stupid, right? Yes, but life is cruel. Deadlines are short. Juniors are coming. So, no, they have also to learn from somewhere, right? Trying to write the tests. If you have to write many such tests, you will feel awkward creating repeatedly big objects just to set 2 fields inside. And like, what the heck am I doing, right? And after calling for the 4th, 5th time that method, it will click. Wait a second, why am I just keep creating big objects? Why can't I just pass the 2 attributes I need, right? First name and last name. Duh. But life is cruel. So that's one solution. Now, there are other cases in which you are facing terrible, horrible complexity. In such circumstances, you might actually introduce a new object. It's called parameter object refactoring. You group A and B in the new object, and you pass that object. Let me tell you. Are you ready? Full name. Omelette de fromage. Good. Now, one warning here. The never mock getters. Some of you, I'm actually afraid to show you that because some of you never had the idea. And now I might give you a terrible idea. Don't ever, ever do that. Others of you feel guilty. I don't want to know who. Do not ever mock getters. We mock behavior, not data. What you should do instead is instantiate your object and fill it up, right? Right, and then one more terrible thing, do not have mocks returning mocks. Who would do that? I don't want to give names, but there are people, right? There are actually companies in the room that do that. But anyway, don't do mocks return mock. It's just nonsense, right? They will be wondering what, wow, it's absolutely horror. Up until here, makes sense? Yeah? No? Simple, let's warm up, like stretching. Next one, I want to introduce you a new concept, a new bit hardcore design concept. It's called constrained objects, I called it. It's like we have data structures that if you try to construct them or somehow lead them into an inconsistent state, they will shout an exception at you. Trying to pass a null as a first name will blow up. This is madness. I mean, like 5%, 10% of teams do that in practice. Objects that refuse to be created with a name too small or doesn't match the pattern or whatever. This is hardcore design option, right? Any one of you familiar with domain-driven design? Maybe you've been playing around, but the rest, unlikely, right? Now, this can work with mutable objects, the ones that have setters, right? Or immutable logic. Can you put a bit louder? No. Leave it like that. Perfect. An immutable object is like paradise. What happens in there? An immutable object is super easy to validate the state of, because all the state comes at once through the constructor. Game over. You validate there, you're done, right? Now, imagine you have such a constrained object, but there is a problem. That object has 25 fields. 25 fields. Out of the 25 fields, there are 7 fields which are required. Do you see the constructor? Can you see the constructor? Thank you, exactly. Now imagine you want to involve this object in a test. How the hell would you create an instance of a class that has a constructor with 7 fields, the required ones, right? This is extremely cumbersome. Do you see the problem? Creating the customer will have 7 arguments. Right. Now, besides this case, there is another one more interesting. This is like a not so likely situation. But the more probable situation is that you want to test a group of classes that you found to have a pretty well-defined responsibility. They are just applying discounts, right? Now, that group of classes has a reasonable complexity. You only need 100 tests. You only need 100 tests. And you might decide to test that cluster of classes as a whole together. Now, to run a test to 100, to run 100 tests to some code, you really need some big objects at the entry to be able to take all the 100 ifs on different branches. You see that? Many flags. Is it the order from Hungary, from Poland, from Romania? Is that with a VAT? Is that a company or a physical person? And so on and so on and so on. So you will have to instantiate a hell of objects, big, huge objects. And again, you would have it cumbersome. Now, since 2006, we have a pattern for this, like, what's that, 18 years ago? Object mother, it's called. It's basically a class, usually called test data. Looking to my colleagues. That has a method, static method, that produces a valid customer. Make sense? Do you see it? And then you can tweak it. Who of you has this in their code base? A class producing objects ready just for testing purposes. Right, so that's like 20% of it. Good. If you do that, that test class, it will be shared between multiple test classes, right? That's why we created it like that, right? What happens next? My mama told me to share people, to share things with people. But sharing in design leads to coupling. Okay, so what happens next? Can you imagine the same customer ran through 2 verticals? What the heck is a vertical? If I say customer order, do you see the 2 packages in your code base? Customer ordering, or the 2 modules, some of you, okay? There are two verticals, two functional areas in your application. Imagine the same customer has to be used here to edit its, I don't know, personal details, and here to place an order. And where does the problem come from? Both of these tests here and here, they use the same class. What happens next? This is coupling between different verticals, okay? So what happens next? People get angry with this. Because if you change something inside this method, you will see fireworks everywhere. Look, like fireworks. Tests that you never knew about blowing up because you changed the shared static factory method. Okay, so what do we do? That's why people call it creepy object mother. Anyway, what do we do? What option can we have? We can take the mother. Okay, that sounds weird, but we can take the mother and cut it in two. Customer test data, order test data. Okay, that's the first step, the first little baby step. What could someone maniac tell you? If you have this maniac design colleague, this architect, this, like, I don't know, super senior, what will he tell you? What? Base class, extends. No, it will not tell you extends. No. It will tell you something more scary. Different customer classes? Oh my God, it will tell you a scary word, bounded contexts. It will tell you, why the heck are you using a single object in 10,000 lines of code here, 50,000 lines of code there? Why? And you say, for historical reasons. But you all feel where this is going. It's going somewhere scary. It's going in 3 months of refactoring. It's going towards modulith, or towards, by the way, modulith, you may not be familiar, is a modular monolith. It's like the new age architecture. Microservice hype is over. Now what do? Modulith. This is what comes after. But the point is, you modularize the code, right? You break the entity in two. That's months of refactoring. Months of refactoring in a normal large project. Make sense? What we discussed? And we started for something super simple, the same instance used in two places. So what? Okay, next one. You should recognize this at some point. Let's see. Your complex logic directly uses APIs or libraries which tend to invade your code. Generating PDFs, generating Excel files, generating graphs, I don't know, you name it. Invasive frameworks. And your core domain logic would find itself calling an API from outside with some details of that external API, or using some DTOs, which is a strange field that comes from ANAF, from the fiscal authority of Romania. All right. 2 minutes response times. Unit testing your logic. Now, unit testing that logic requires you to understand the actual semantics of the API details and the DTOs, right? You need to become expert in what enough DTO looks like. Is that what you want out of life? Is that your definition of happiness? God, never, no. Or if using that horrible library I mentioned with some mysterious parameter, if you want to test the code, the logic as it is, you will have to mock, when, then verify this method. What does that mean, understanding the quirks and details of that library? Okay? So you need to become an expert in the library next, right? So what's the solution here? Where am I going? No. Where am I going? Anyone? No? Ever heard? Yeah. 3, 2. Push it outside. Push it outside. Where? Ever heard of the onion architecture? Hexagonal clean ports adapters, the same thing. That's where I'm going. You should do what? You should keep your logic in a place that has nothing to do with the outside world, with enough, for Christ's sake. So what would you do? An adapter on front of the enemy. And then you just mock and fake and talk on the adapter. And you would only see your own objects, my own. My objects. Not enough objects, right? So this is where I'm going. I want the tests to be written in my world, in my domain, in my language, right? This is especially important for boundary systems talking to the external of your company, also with very invasive libraries, right? So respect the tests. Make your tests talk the same language as the rest of your application. Make sense what I'm saying? Yeah? So basically, you wrap the code into another class, and you stop your logic at that class that you created. It's called the adapter design pattern. Okay. Okay. Close one eye and listen to me. Like, relax and listen. In the center, there is domain. Let me put the proper music for domain. Domain. Entities, aggregates, value objects, domain services, interfaces for adapters implemented outside, dependency inversion. Interfaces after which you can find adapters for libraries, right? This is a domain, and outside is anything else that has to do with the outside world, right? I'm not going to introduce to you all architecture at this time of the day, but read more if you want. Good. So the unit tests love precise signatures, smaller structures, and agnostic domain. So pass only what you need, create new structures, and mind that you only use the objects that you have under your control from your application, your domain. Good? Next. Chapter 2. Unit testing puts design pressure on very complex logic. Design pressure. What the heck is that? I mean, like, you've just poured some ifs in there, more features, shipping features after feature, then at some point, that kind of complexity doesn't have sufficient, let's say, structure. It collapses. You find yourself doing ifs everywhere, doing bad things. You wake up at night sweating. Oh my God, I have to confess these sins. At some point, that amount of features don't need more structure, need more design. Who tells you about that? Mock scan. Look, mock test scan. Imagine a function f calling g in the same class. Are we good? F calls g. Nothing wrong. What can be wrong? The problem is when both functions grow complex. If both functions grow complex, something weird happens. If g needs 12 tests, 7 tests for this function only, 12, let's play 12. 12 tests. You will be thinking, how do I test g alone? Right? Because it's complicated. If this has 12 tests to write, and this 10 more, it becomes complicated. So let's test g in isolation. You unit test g in isolation. You take g, you fire tests on that. But then you turn to f. And you ask yourself, when I test f, do I want f to execute g? I've just tested g. I've put tests on it, right? And now I'm testing f. So look, let me draw something. I've put tests here, tests on g, many tests, right? This is heavily tested, 100% mutation tested, you can't break it. And then you come with a test on f. And you ask yourself, would I want, when this test enters f, to go through g? Try to do that. I beg you, try to do that. But at some point, passing a call through g will blow up the tests you put on f. You see the point? What can you do? Exactly. Not spies. Spy is a very evil thing. You say, when calling f, mock g in the same class. Can you imagine this? In the same class, one real method under test and another one being mocked out. You know what that sounds like? That sounds like hell. Years later, months later, one day later, you will not know what method is real and what method is mocked. Do you feel it? You will wonder, is that the real method or did I just mocked it away? So this is how hell looks like, right? Not knowing if when you talk to a method is a real method or a fake. Okay, so what to do? Take f, take g, take your friend, and cut the class into high level, low level. What does that mean? It's called split by levels of abstraction because the class that remains with f inside is on a higher level than the other class. What do you mean higher level? It's the orchestrator, it's the coordinator, it's the application service, it's the boss. And this guy just, I don't know, computes the discounts. Not the whole price, check out, I don't know. Like high level, low level. So tests will tell you to break classes apart, will hint you, right? So what happens next? You might feel not okay. You might feel these two don't really need to be broken up. Because you know what's the symptom? You can't possibly find a name for the other class. And you could go circles and circles. How would I name it? You ask a friend, you have a glass of wine, you ask your wife, no one knows. And then you say, I can't really do that. So what do? You can merge them back, leave them be as a single class, but put more heavier, longer tests on F. Usually that requires creating a bit of testing framework, a scaffolding, like an infrastructure just to be able to fire long tests in that F, right? But that's the trade-off. Right? But very often you can just cut it, and if this has a sound responsibility, extract a separate class. That's when you split the class in high level, low level, in a sense, vertically. You break it like that. Why is it high level? Because this calls the low. Make sense? Even at 522 in the, okay, wow. Wow. Next one. You find one class with two complex methods. Let me prepare you. I'm going to show you how tests can help you break stuff, not vertically, but horizontally. We have a class with two unrelated functions, both complex. These functions both one uses the blue one, the other one uses the yellow one. Are we good? We love colors, right? Yes, colors, perfect. Now, if you want to test this class, you will have to mock A and B, right? Because some tests will target complex A, other tests will target complex B. Make sense? Right. What happens next? Because you have to write 5 tests, and all of these 5 tests need to control what this function will return, right? Mock this function. You will have to repeat yourself 5 times. When then. At some point you say stop, and you will say, don't repeat yourself. Let me take that part and put it in the before. Right? Of course. When you don't know where to put something, you put it in the before. Right? It's called gena in Romanian. Good. You put it in the before. You ship it there in the before. Perfect. And the same you do for the other one. What happens next? Do you know? What happens if you do that in Spring Boot 2.0? Fail. It will fail. What's the reason for the failure? Because these two, basically, the testing framework will tell you, you never used this baby when you called complex A. Complex A used the blue one. You mocked the yellow one, not used, exception. This is big. Mockito crashes, the framework crashes, saying, why are you stopping this method if you're never using it, right? So what's the underlying problem? Why is this such a big deal? Because if you have one test failed in here, you would look at the before and you would start wondering what of these 7 lines is mine and what is not mine. You see it? And those guys creating the mocking framework, they saw us doing this stupid thing. So they blocked us, saying, no, you should not do that. And don't cheat with lenient and stuff. All right, good. So that's called fixture creep. Fixture is a fancy word in testing, meaning setup. Fixture creep. It keeps expanding to serve all the tests in this class, right? Now, one option you have here is to take this test class and break it in 2, right? Break the test class. One for A, one for B. All good? Simple. What would be the next step? What? The guy pulled out the bazooka. I can fix this, just step aside. To have a clear view. Wait. I find parameterized tests often abused. If you have 3 cases to test, don't make a parameterized test. You need to have 10, 7, something table-like. You need to debate with the business on an Excel. If you debate with the business on an Excel, Write a parameterized test. No, don't. Write a feature file. Send the feature file to the business, get it signed, and run it on Jenkins. Another story. By the way, afterwards, we can stay for as long as you want to debate stuff in code. I have a lot of code to show you if you want. If anything here catches your eyes, I will be here waiting for you. 15 minutes, just good. So, now, even worse, even more brutal. What can someone maniac do here? Nested test could work. What else? Split this one. That's why it's called wide. Split it, of course. I mean, like, why are these complex things sitting in the same class? Right? Break it apart. A and B. You see? Two classes. Hey, we just split the class horizontally? Ha! Isn't that cute? Nice. Does it make sense? Why is it horizontally? They are at the same level of abstraction. If that was a service, now we have two services. If that was a repo, then we have two repos. Right? Okay. Now, okay. So tests give us hints on how to break complexity vertically and horizontally, but should you always follow these hints? I already hinted you, no. No, because sometimes you can't name the other class, right? You take circles, you ask your wife, you have a glass of wine, you can't name the class. That's a problem. It means it doesn't have a sound responsibility. 19 years ago, some people in London, I think, were experimenting a bit. 19. Who of you has more than 19 years in this wonderful profession? I don't. 1, 2, 3, of course. Okay, like what? 5? In 2004, these guys were inventing mocks, and they were the first. And you know, this is a scientific article, the one you write for PhD, for example, right? And it was science back then, right? And those guys were the first to lay their hands on mocks. And they said, mock roles, not objects. What the heck is that? Right? And they tell here, if you just read the article, it's a brilliant article. It tells about, I don't know, at least 3 or 4 bad practices you are doing today. Okay? So these guys said, mock role, because that was the worst thing. Mock roles, not objects. What does that mean? Folks, you implement a new feature. Click, 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 it works. If it works, yeehaw! And then, tests. I forgot about unit tests. Damn. And I can't push code without tests because it doesn't accept the code review, the blah, 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 the blah, 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 yeah. Tests, oh my God, tests. So then you write tests. And what do? You take all the dependencies of the classes you created and you put them in the test. Mock. Of course. That's a bad practice. Because several years later, you will complain that your tests are impeding refactoring, breaking every step you take. They are fragile, they don't help you go faster, they help you go slower. That was what these guys were trying to say 19 years ago. Don't just mock blindly an object. Clarify its role before you mock it. Because once you mock a method, it freezes. It is 3 times harder to change the signature, to break a function into. So refine the roles. Make it very clear. You can explain to your wife, she's a medic, what that function is doing, right? It's doing that, or that contract is going. That's called contract-driven design. Don't think about the roles more, knowing that if you put a mock on a contract, you lost it. That contract it's very hard to change later. Make sense what I'm saying here? Review again. This is one of the most advanced and let's say, not confusing, the most, how to put it, not sharp point. If you want, I have some examples. If you want, come afterwards and I'll show you. And then, all this, you ask at code review, why did you do that? That bad habit. Because, he says, that's what unit testing means. Wrong. Let me put Jan Cooper, because who am I? Who is Jan Cooper? Let's hear the guy. I'm not connected to the... It says, I quote, "It's perfectly fine," let me zoom in, "it's perfectly fine for unit tests to talk to database and file systems." What do you mean? I mean, unit testing is not about testing a single method. It's about testing a responsibility, a role. If that involves a database, Docker. It involves API call, Wiremock. You don't necessarily have this. So unit testing in this sense, unit testing doesn't mean testing method by method. If you do that, your tests will become extremely fragile. They will not help you on the long run. Before you test or you mock stuff, identify responsibilities. Now, there is a tricky thing that happens. If this is the time frame you have to implement a feature, when do you start testing? Here? Here? Outside. In the next sprint, exactly. Just ship it. There are circumstances in which this is the best business decision. Of course. I'm not a maniac. I'm an adult, right? We have to do trade-offs, Black Friday, Christmas, shipping, software, I don't care, games, you have to ship it, right? What do you do in the next sprint? You don't answer the phone. Not you, not the whole team, you're doing tests. Repenting. Now, really, if you hear the big guys out there, they will tell you, test here. They will tell you, test here. What do you mean here? What do you mean here? Write a feature file with the business analyst, behavior-driven madness. Okay. Let's get it real. I mean, like, okay, we are living in Romania. So, I don't know. Not here. Maybe I will put here 50%. Maybe here. Anywhere here is good for me. Right? But why? Why is it so important? Because, you see, the earlier you start thinking about testing, the earlier you understand the requirement, really. You know that moment when you wanted to write the first test and you went like, and you called the business, and he said, that moment. The earlier you have that moment, the better for the entire project, right? Also, if you have written tests here somewhere, you get more time to repent and to change the bad design you put in there. Right? If you started testing here and you found out you have to do a refactoring of 2 days, you will say, right? And the third thing, given that you really did tests strongly, it will give you the courage to refactor later. So I'm not a religious guy to say TDD or you're stupid, like some of them out there. No, test around here somewhere. Right? As soon as you understood the problem within the code, many people at the beginning of their career, they need to write the code to understand what they're doing. They think in code. Do that. But the moment it clicks, you understand what you have to do, you have a clue, write some tests, throw it to the business, maybe even feature files, and hey, is this what you want? Right, good. So, breaking stuff horizontally, vertically, and identifying roles. This is what tests want us to do. Okay, what next? Unit testing promotes functional programming. Functional programming.
Gangnam Style.
Ha! Right? Java discovered functional programming. Anyway, yeah, in some faculties you don't even hear in Romania about streams. I'm so angry with that teacher. Anyway, so I'm talking about here not the fancy thing of taking a lambda and throwing it to someone. No, that's not really functional. What functional programming really talks about in terms of design, I'm nervous. Venkat is looking at me and I'm stepping on. In my humble opinion, functional programming means pure functions and immutable objects, right? Means that's the design. You need to promote more pure functions. What the heck is a pure function? A pure function, and we love them, a pure function doesn't have any side effects, doesn't change anything, not even a field. Not to mention sending a message or posting on, nothing changes when you call a pure function, okay? Okay, and one more. A pure function gives you the same result the second time you call it with the same arguments, right? This means you are not allowed to touch network, get, select, not allowed. You are not allowed because you don't know what the second time you call get. You don't know what it will give you the second time you call it, right? So basically, pure functions just compute a value, right? So if you want a super simplified version of this, pure functions don't do network, don't change data. They don't do network, can't touch the network.
Can't touch this. You can't touch this.
Good. So you can't change, you can't do any network, right? Simple. Now, because they don't touch network, they are extremely fast in practice. Extremely, insanely fast. Nanoseconds, right? And because you want to prevent them from changing anything around them, you will pass them and take from them immutable objects. Okay, so how does that help us? I promised the headache. Can you feel it? It's starting from the neck, going up in places you never knew you had. It's the first time it hurts you in that part. Excellent. Now, repo find, API call. Life, hashtag. Good. Complexity, like computing discounts. Repo save, message send. Okay. I've seen worse, right? I'm sure it did. Okay. So you have some really complex logic using some dependencies in there. What would testing require you to do? Can you see them? Can you see them? Mocks, because it's complexity in there. Ooh la la. So what do you do? I will be kind with you because we don't know each other that well. If I had a full day with you, I will unleash. But reduce coupling of complex logic. That's how you start. Reduce coupling of complex logic. Now, what would I do? I will take this part from here, pull it out. Out where? In a separate pure function. Immutable in, immutable out. No network. Okay, so what happens next? Testing becomes a pleasure. You pass A, B, C in, you get D, and you assert D. Done. You know what's that? That means tests without mocks. I should make myself a t-shirt. I test with no mocks. Right? Folks, why are mocks bad? Mocks make your tests fragile, can lead to bugs in production, but green tests, so annoying, right? So try to test the real thing. And if necessary, extract that thing that scares the shit and put it out, test that. There is some fine print there if you want to know more, come afterwards. Like, would I test that? What happens? Can this be static? Yes. There are some subtle things in there. If you want, you can come and debate more. So this would lead to something very fun. I would pull all the complex things into a place called functional core. Thank you. This is his slide, but anyway. Functional core, which contains all the complex logic I have. Calculations, right? Just calculations. This is the standard architecture in a purely functional language like Haskell, if you ever heard of that. Now, outside of this functional core, we have an imperative shell. We have an area in which I do anything which is not pure, meaning network or changes to state. You see the point? So it's like if you want to talk in my more backend terms, application service is there, and some of the calculations, I can make them pure functions. In, out, in, out. This is called imperative shell functional core segregation. A better picture is this. Huh? All right, so this is what just happened. I extracted from this madness of complexity only that part that was really, really doing many ifs and computations, extracted it out. I told you, there are many fine prints about this. If you want all the details, come afterwards and we'll debate. If the headache didn't went. Okay, good. Next, you have 4,000 unit tests. Who here has more than 10,000 tests? 10,000 in his system. Wow, have a happy monolith, 10,000 tests, wow, bravo, bravo. 4,000 unit tests, 100% real test coverage. But you use mutable objects. So what? Mutable order, discount service, apply discounts, order D. Semicolon. This semicolon, oh my God, this semicolon. What's wrong with that? What would this function do? Do you suspect? Change the order. It can't do anything else because it doesn't return anything. It will oh my God, it will change the order. Oh my God, it's going to change the order. And then, you know what I do? I swap this line with this line. Whoop. Exactly, yeah. 4,000 green tests on Jenkins, bugs in production. 100% test coverage, right? Folks, 100% test coverage has one team in 30 in Romania. That kind of, you don't see that, right? All right, so what happens? This is called temporal coupling. You could play the paranoid testing strategy here and check the order in which the method is invoked. Don't do that. That's a mistake. You're going too far. You need to change the mindset towards a more pure, a more functional mindset. How does that work out? You would want to promote more immutable objects. Let's see what happens if I play immutable object. By the way, a stupid question. Is this a pure function? No, it changed the order. Yes, but at 6:30 in the evening, not a pure function. Good. If this were a pure function, it had to return back the changed order, isn't it? This is the only way you could change an immutable object, by cloning it and changing a field in the clone. Ha. So what happens if in the bottom code that you will barely see, what happens if I try to invert 2 lines in there? Can you see? What will happen if I change these 2? It will not compile, exactly. It will not, ladies and gentlemen, it will not compile. Yeah. Yeah. I don't need tests for that. The compiler will tell me how stupid I am, right? So this is what you get. Like, this immutable objects complement testing. It's a philosophy that you can adopt to reduce from the compilation some stupid things we do. That being said, I have a client in Belgium that if they see you reassigning a variable, compilation fails. Git does not accept your push if your push reassigned a local variable. If you want to meet the guy who made this possible, join this talk on May. He used a plugin for a compiler to make sure, it's called error-prone from Google, that basically it's able to detect if you reassign the variable. And by the way, in their code base, there is no, how to say it? All the objects are immutable. Completely 100% immutable. You cannot change absolutely anything, not even in the toilet. In the toilet is immutable. Everything is, all right. So, I think we kind of reached the end. What did test tell us? A bit of a summary. If you find a method not doing much, just calling 7 other methods, one mock, 2 mocks, 3 mocks, 4 mocks, 5 mocks, 6 mocks, stop, 7 mocks, ask yourself, what am I testing here? What will be the solution? Destroy that method maybe. Or even better, test the whole flow, right? End to end from the API. If you run just one test through that method, you're done. So why not run it from the API level? 3, signatures to take the least amount of information the function needs, the structures to be tailored for what complexity you have in there, even leading that down to breaking an entity into bounded context. That's 3 months of refactoring. If you want hints of how to convince your boss about that, come and talk to me. Boss, 3 months, I won't ship you any feature. How do you say that? How do you sell that? How do you do it? There are tricks. By the way, you should not say that, exactly that. Keep complexity in an agnostic domain that knows nothing about the outside world. That's hexagonal or onion architecture, right? Separate complexity, vertically, horizontally think about roles, right? And promoting functional programming, how? The more complexity you have in a function, the less dependencies it should use to make it easier to test it without mocks, right? And in the end, you saw the 4,000 tests but bugs in production, right? Immutability, please, right? So I think I missed to show you one slide. I wanted to insist on that, but it crossed my mind. At the beginning of this discussion, I put a slide on you on which some friends that I have would have already screamed. Wait a second, where are you? Come on. It was over there. It was immutability. Here. Is this mutable data in 2023? So try to make it more immutable, everything you do. Good, so testable design is a good design because otherwise the test will make your life a hell. So writing fine-grained unit tests earlier would increase friction with stupid design. In other words, you won't survive to finish the feature if you put tests before the half of your time frame, because your life will be miserable testing it, right? So you will have to change production code to improve production code. Take a photo to read. Okay, take a photo. 3, 2, 1, and I will share the slides on Twitter afterwards anyway. I tricked you, all right? And so write more automated tests earlier to have time to listen to what the tests are trying to tell you. And if you want to join the community I kept telling you about, this is the QR, completely free scan, and we can hear each other on 30 May talking about API security vulnerabilities. And with that, I thank you all for listening to me, and I will wait you here with the code if you want to debate.